Inside the guidance system of a single precision-guided missile or the generator of a deep-sea wind turbine lies a fraction of an ounce of a highly specialized element. On its own, this microscopic speck of matter is barely visible to the naked eye. Yet, without it, the multi-million-dollar weapon platform is rendered inert, and the multi-billion-dollar green energy transition is brought to a grinding halt. This is the paradox of the modern industrial economy. We build a civilization dependent on materials few people ever think about. This is a red line, where we uncover the hidden systems, decisions, and forces shaping our world. And today, we explore how China quietly gained control over one of the world's most important supply chains. While the United States and its allies possess some of the most advanced engineering labs on Earth, it is Beijing that controls the invisible machinery required to make those designs physical reality. To put this in perspective, owning a rare earth mine in the West without access to Chinese processing infrastructure is like owning a vast field of crude oil without possessing a single refinery. You are left holding a mountain of useless, toxic dirt, while your strategic rival holds the keys to the entire global supply chain. To understand how we arrived at this state of asymmetrical vulnerability, we must look back to the closing decades of the 20th century. This was not an overnight conquest. Rather, it was a deliberate, generational strategy executed with cold, mathematical patience. Historically, the United States was a self-sufficient pioneer of the rare earth industry. Throughout the mid-20th century, the Mountain Pass mine in California was the undisputed global hub for these critical minerals. But rare earth elements are not, in fact, rare. They are highly dispersed throughout the Earth's crust, mixed together in low concentrations with highly toxic, radioactive byproducts like thorium and uranium. Consequently, extracting them is a brutal, dirty process. In the late 1980s and 1990s, Western nations face a choice. They could either invest billions in upgrading their environmental safeguards and maintaining expensive domestic facilities, or they could outsource the ecological liability to a developing nation eager for industrial growth. They chose the latter. As Western environmental regulations tightened, China's industrial leadership saw a systemic opportunity. In 1992, Chinese leader Deng Xiaoping famously remarked that while the Middle East had oil, China had rare earths. Beijing began heavily subsidizing its domestic mining operations, deliberately undercutting global prices to drive Western competitors out of business. The strategy worked flawlessly. Within 2 decades, Western mines were shuttered, their intellectual property acquired, and their processing equipment sold for scrap. The market had functioned exactly as designed, optimizing for the lowest possible short-term cost. But in economic terms, this efficiency came at a devastating strategic price. The West had successfully exported its environmental footprint, but in doing so, it had surrendered the foundational capabilities of its high-tech industry. Indeed, the closure of Mountain Pass in 2002 marked the final capitulation of Western domestic production. What the West failed to realize was that the mine itself was never the true source of power. The power lay in the complex chemistry required to transform raw ore into highly specialized magnets and oxides. By allowing these chemical skills to atrophy, Western policymakers effectively dismantled their own industrial independence, leaving their future supply chains entirely at the mercy of Beijing's long-term geopolitical planning. To understand why this monopoly is so difficult to break, we must examine the punishing, highly specialized logistics of mechanical breakdown. The public discourse often conflates mining with processing, but in the world of advanced materials, extraction is merely the prologue. The true barrier to entry is the chemical refining. When a rare earth mine operates, it digs up a mineral concentrate containing a mixture of 17 different elements, all tightly bound together. Because these elements share nearly identical atomic weights and chemical properties, separating them is a monumental technical challenge. It cannot be done with simple heat or basic mechanical sorting. Instead, it requires a process known as liquid-liquid solvent extraction. To put this in perspective, this process involves passing the raw chemical slurry through hundreds, and in some cases thousands, of sequential acid-filled vats. Each individual stage of this vast industrial labyrinth utilizes highly toxic solvents to peel away a fraction of a single element at a time. It is a slow, capital-intensive, and hazardous feedback loop. Crucially, This process generates massive quantities of highly acidic wastewater and radioactive residue. In China, massive industrial complexes like those in Baotou, Inner Mongolia, have been engineered to run these toxic cycles at a scale and a cost that no Western corporation can legally or financially match. The environmental externalization is staggering. To produce 1 ton of refined rare earth oxides, the system generates thousands of gallons of toxic wastewater and substantial quantities of radioactive waste. Consequently, even if a Western nation opens a brand new mine today, such as the renewed operations at Mountain Pass or deposits found in Sweden, they face an insurmountable wall. They can dig the rock out of the ground, but they cannot legally process the chemicals on-site due to strict environmental regulations. Ergo, they are forced to ship their raw, unprocessed, or across the Pacific directly to Chinese refining facilities to be processed by the very adversary they're trying to bypass. Without the chemical infrastructure, the mine is merely an expensive hole in the dirt. Furthermore, the process does not end with chemical separation. Once you have isolated pure neodymium or dysprosium oxide, you must convert these powders into specialized metallic alloys, and then precisely machine those alloys into permanent magnets. This final step requires proprietary metallurgical techniques that China has spent 3 decades perfecting. The manufacturing of these magnets requires extreme precision, as even the slightest microscopic impurity can ruin the magnetic properties required for high-tech applications. Because Beijing has spent decades optimizing the specific industrial niche, they hold a virtual monopoly on the patents and specialized machinery required to manufacture these high-strength magnets. The entire system is a closed loop, owned and operated within Chinese borders. This brings us to the geopolitical chessboard, where this industrial bottleneck is leveraged as a tool of raw, asymmetric power. In the realm of modern warfare and economic competition, rare earth elements are the ultimate choke point. Historically, Beijing has demonstrated a clear willingness to weaponize this vulnerability. In 2010, following a maritime dispute near the Senkaku Islands, China abruptly halted all rare earth exports to Japan. The Japanese high-tech sector, heavily dependent on these imports, scrambled to find alternative sources. Though the embargo was unofficial and temporary, it sent a shockwave through global capitals. It was a stark demonstration of a simple truth. Economic interdependence is not a shield against conflict, but a weapon to be used within it. Crucially, the threat has only escalated in recent years. As geopolitical tensions rise over Taiwan and technological supremacy, Beijing has begun tightening its grip on these supply chains. Recently, China introduced sweeping export controls on gallium and germanium, metals critical for advanced radar systems and semiconductor manufacturing, as well as restrictions on graphite, a key component in electric vehicle batteries. These measures were not merely retaliatory. They were a calculated display of structural leverage. Beijing is sending a clear warning to Washington and Brussels. If you restrict our access to advanced microchips, we can choke off your access to the very physical elements required to build them. In this high-stakes game of economic coercion, the West finds itself in a deeply compromised position. The Pentagon estimates that each F-35 fighter jet requires hundreds of pounds of rare earth magnets to operate. Every security-critical submarine, every precision-guided missile, and every sovereign satellite constellation is structurally dependent on a supply chain that terminates inside the borders of its primary geopolitical rival. The leverage is absolute. While the United States can deploy aircraft carriers to project military power, Beijing can quietly halt a few shipping containers of dysprosium and functionally freeze the production lines of the defense contractors that supply those very carriers. The realist verdict is both simple and sobering. There are no fast, clean, or cheap solutions to this systemic crisis. Despite the sudden flurry of Western government subsidies, tax credits, and strategic alliances aimed at friendshoring the supply chain, the underlying laws of chemistry and economics cannot be bypassed by legislative decree. To build a fully independent Western rare earth supply chain, from extraction to chemical refining and ultimately to magnet manufacturing, will require decades of sustained capital investment, a massive tolerance for environmental risk, and a complete restructuring of domestic regulatory frameworks. Historically, Western democracies have struggled to maintain this level of long-term strategic focus, which is constantly disrupted by short-term political cycles and volatile market forces. To put this in perspective, while a private Western mining company must answer to impatient shareholders demanding quarterly returns, Beijing operates on a multi-generational horizon, insulated from the immediate pressures of market profitability. Consequently, any attempt to decouple from Chinese processing infrastructure in the near term is a mathematical impossibility. For the foreseeable future, Western nations must accept an uncomfortable, realist reality. They will continue to operate within the structural constraints of an industrial ecosystem that was designed, optimized, and ultimately conquered by their chief competitor. In the modern geopolitical arena, power is no longer measured only by armies, but by who controls the supply chains that make them possible. This was the Red Line. Subscribe to understand the hidden forces shaping our world.